What are you doing here? I'm here for an important meeting.
Hello everyone. Called y'all here today for a very, 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 very top secret important mission. Retrieving the stolen Dr. Pepper secret ingredient. No need to panic. I have the plan. Or I did. I left my notes in the other room. I'll be right back.
If this is a group mission, I think I should take leadership.
Well, I'm Thor, and none of you pathetic humans can defy my natural godly power. You may be smart, ironing woman, but you are all machine.
Well, no, I have the most intelligence, so obviously. Hulk is just a giant rock.
Hulk, aren't you angry? She just insulted you.
Nah, I'm angry managed than Hulk. I don't get angry anymore. Except for when there's a dead body. Or blood. Or, texting and driving. Mr. Keeneland. I hate that stuff.
Hey everyone. I have here in my hands the perfect plan. You will all approach the enemy in a periodic formation.
Oh, Nick Fury? Aren't you supposed to be black?
Well, now everything's black, all of you, so that means I'm black too. Everything's black now. Hulk, you're gonna cover the rear, but first, you have to cover your rear. Thor, you're gonna be in front of Hulk, and then it's gonna be Ironing Woman, and then we're gonna have Captain America in the front.
That's an awful idea.
Yeah, we're superheroes. We need a proper plan.
Strategically, this will not work. We aren't utilizing our capability at full extent.
No, guys, this will only bring more anger, dead bodies, texting and driving, etc.
No, this is not a noble thing to do. We shall take this mission in our own hands. We don't, Nick. We got this.
Wait, you guys, don't leave! Ow! My eye patch! Okay, well, a long time now. Millions of things that I do. Out of all of them, I'm gonna do my chem homework.
Remember when Nick told us to line up in atomic size? I don't think that's a good idea.
Arrange the following atoms in order by increasing atomic radius. Fluorine, francium, Phe, and helium. I'm gonna need a periodic table to do this. Oh my goodness! Periodic table! Woo! Okay. Well, before we get started using this, I'm going to try to explain a few terms that I will be using. First are families, family groups. They're essentially our columns on the periodic table. You have main ones being the alkaline metals. These are pretty reactive. And then you have your alkaline earth metals in 2A. Then in here you have other various metals, a wide range. Here along this line are the transition or semi-metals. Over here you have non-metals, which usually are seen as gases. And then here are the noble gases, which are fairly inert because they're all pretty satisfied. Their valence shells are full of electrons. Another term are periods, which are rows on the periodic table. These are usually not labeled because it's fairly evident 1, 2, 3, 4. And these are just mainly used for determining atomic radius as you go further down. Okay, so fluorine, francium, iron, and helium. Okay. Well, on the periodic table, noble gases do have the smallest radius. And then as I move further left, the atomic radius gets larger. So since helium was one of my choices, I'm going to put helium's my smallest because it's furthest to the right. Then I have fluorine. That's going to be pretty small because it's really close to the right. Next one is going to be iron. And then finally francium, which looks pretty massive. This begs the question, why are they all different? Why is there this trend? Well, when we look at noble gases, there's pretty much an equal ratio between the protons and electrons. So the protons can bring the electrons in a little bit closer, so the electrons don't go orbiting around too far from the nucleus. Same with these, there's a pretty close ratio, but when we get to the alkaline metals, the electrons are very far apart from the protons in the nucleus, which makes the radius larger as we go from right to left. Now, when we go from the top to bottom, as we go down the periods, then we add on more protons, more neutrons, and more electrons. And that just naturally, we add more orbits, so that just naturally makes the atom much larger. So that kind of means that for atomic radius, it gets larger this way, and larger this way.
I think we're in the right place.
How can you be so sure?
Whoever stole it left some here.
Secret ingredient.
Look! There he is! The guy with the receding hairline, hunchback. He might even be bigger than me.
You there, stop! You're the lead electronegative. Get it. What? Where's Ironing Woman?
Just because you seem noble and you have the word captain in your name does not mean you can tell me what to do. My, I'm so pretty.
I need a plan to stop Keelan.
In the name of alkaline earth metals, I will stop him!
Crap it on this movie, get out of here!
What's wrong?
I'm not in the movie.
Okay. Anyways, continue on my next homework problem. Which element on the periodic table is the most electronegative? That's question 1. Question 2. Arrange the following atoms in order by decreasing electronegativity. Iron, francium, fluorine, and helium. Okay, so arranging iron, francium, fluorine, and helium in order of decreasing electronegativity. Obviously, fluorine is going to be the most electronegative. So fluorine. And then to determine whether or not something else is the next highest electronegativity, we just need to see how close it is to fluorine. The trend on the periodic table for electronegativity kind of goes in this diagonal pattern. There's a diagonal that goes across, that would go across the periodic table, that would point to fluorine. Essentially meaning this way and this way. That would mean that iron here will be next one that's electronegative. And then we have francium here. It's going to be the one the least electronegative. But the noble gases here have no electronegativity at all because their valence shells are already filled with electrons. They do not need any more electrons to be satisfied or to be stable. Because of that, all these have the same electronegativity, and if it was to be measured, it would be 0, essentially. So that would make any noble gas the least. Oh, what a feat.
Now that Spidey's gone, it seems that the atomic radius plan isn't working. Keeneland still has the Dr. Pepper secret ingredient.
What are you? I'm here for an important meeting. I'm supposed to come in.
Yo, when you're ready.
Well, I'm ready, so just walk in whenever.
What's so funny?
Walk it down and be like, where's the dope man?
Have the ending, like the ending, just the ending, the very end just shows like this or something.